To solve trig equations here in the second section of chapter 6. We're going to jump right in. There's several different methods we'll use to solve. Some you can see here are bilinear methods. We'll do some factoring. We'll do some quadratic formula, and we also might do some squaring. But starting with, we've already seen something like this back in chapter 5 when we substitute our double angles in. To solve the equation 2 sine theta plus 1 equals 0, the first thing we want to do is isolate the sine of theta. So our first step is to subtract 1. And to get sine further by itself, we'll divide by 2. So the sine of theta equals a negative 1/2. So then, probably the best thing to do is pull out that unit circle and find out where does sine equal negative 1/2 at. That happens at 210 degrees. Notice the interval from 0 to 360. And it also happens at 330 degrees. Then, letter B says for all solutions, well, if I put that on the coordinate plane here, I'll start with 210 right here. 210 would be this angle right here. That's where we have a negative 1/2. But if we went all the way around, we'd have that angle. Or if we went all the way around twice, we'd have that angle and so forth. So we have, for all solutions, 210 degrees plus 360 times n, just number of revolutions we're going to make. So the same thing would apply with 330 degrees. We keep going around a revolution, and n can be an integer, so we could go negative angles as well, but we're going to add 360 to get those coterminal angles. We'll move on right away here to solving the equation of square root of 3 times tangent minus 1 equals 0. Start the same way. We'll add 1 to both sides. So the square root of 3 times tangent equals 1. We'll divide by the square root of 3 to get tangent by itself. Tangent theta equals 1 over the square root of 3. If we rationalize the denominator, we get square root of 3 over 3. So between 0 and 360 degrees, tangent has a square root of 3 over 3 positive in the first quadrant at 30 degrees, and the third quadrant at 210 degrees. Now notice here, a little bit different. Our tangent is positive in quadrant 1 and quadrant 3. Well, quadrants 1 and 3 are separated by 180 degrees, so we can cut this one down for all solutions just a little bit and say 30 degrees plus 180 times n. Okay, so we're going around from 30, add 180, we get 210. We'd add 180, we get back to the first quadrant, and 180 back to the third quadrant, and so forth. So a little bit simpler version there for our all solutions because tangent is every 180 degrees. So a couple of quick examples there to get us started solving an equation, simple two-step algebra equations using our trig functions. Let's go back to the top here. It says to solve by factoring. So if we want to solve by factoring, we have to set our equation equal to 0. Sine theta times tangent theta minus sine theta equals 0. So I move this sign over by subtracting. We want to set it equal to 0, much like if we had x squared plus 5x plus 6 equal to 0, we could factor that as a pair of binomials and move forward. So I'm going to go this route first. This would be x plus 3 times x plus 2 equals 0. Here we have a greatest common factor of sine. We'd be left with tangent theta, minus 1 equals 0. As we did in algebra, we take each factor by itself and set it equal to 0 and go ahead and solve. So I'm going to repeat the process here. Sine theta equals 0. Tangent theta minus 1 equals 0. Over here on our unit circle, sine equals 0 at 0 degrees and at 180 degrees. And tangent, we have to go a step further. Tangent theta, I'll add 1 to both sides, equals 1. Tangent equals 1 at 45 degrees and in quadrant 3 at 225 degrees. Just looking right straight off our unit circle. So this time we have 4 answers, 0, 180, 45, and 225 as we go around our circle, unit circle, because of the factoring involved there. Have another factoring on here. Notice number 4 is a trinomial. So I'm going to set up my 2 blank sets of parentheses. To get tangent squared, I can take tangent times tangent. To get negative 2, I can take 2 times 1. I want a positive 1 in the middle, so my 2 is going to be positive, my 1 is going to be negative. We're set equal to 0. So each factor is set equal to 0. Tangent x plus 2 equals 0. Tangent x minus 1 equals 0. I'm going to start here because this one is on our unit circle. The tangent of x equals 1, or tangent of x equals 1 at 45 degrees, which is pi over 4, and at 225 degrees, which is 5 pi over 4. So notice our interval has changed to be in radians, which is going to complicate things just a little bit here for our other one. But if I subtract 2 from both sides, tangent x equals negative 2. You'll probably notice as you look around the unit circle, tangent does not equal negative 2. So that means I'm going to grab my calculator and I'm going to use the degree version first. So I'm in degrees, and I'm going to use inverse tangent of negative 2 to come up with our degree measure. So notice that's negative 63 degrees. Okay, I'm going to make life simple and say it's an even negative 63 degrees. Well, negative 63 degrees, first of all, is not a radian measure, so we could convert that over by multiplying by pi over 180. But more importantly, it doesn't fall between 0 and 2 pi, or in degree measures 0 and 360. So to make it a coterminal angle, I would add 360 degrees, so negative 63 degrees is the same thing as 297 degrees. Oh, just a sketch of that. Negative 63 would be down here, this angle right here. Well, we'll measure that as a positive angle, coterminal, way back from chapter 1 or 2, so that is a 297 degree angle. That falls between 0 and 360, or 0 and 2 pi, at least as a degree measure. We've already talked about the fact that tangent will also be negative in quadrant number 2, so from here we would take that 297 and subtract 180, so my other angle is 117 degrees. Now, as I mentioned earlier, we could multiply those by, let's go back, by pi over 180 to convert those to radian measures and have our other two answers. I'm going to go back to the calculator version. Now that we've walked through the entire step, I'm going to change my calculator to radian mode. And it didn't go down, so I need to go down again. Oops. There we are, so enter. And then I'm going to go back and type in the inverse tangent of negative 2. Again, gives me a negative angle. That angle will be in the fourth quadrant. So over here with the 2 with negative 63, we added 360. Well, instead of adding 360, I'm going to add, in terms of radians, I'm going to add 2 pi. So one of my answers is going to be 5.176. Okay, so I'm going to get rid of this. One answer is 5.176 radians. Notice that's the same thing as 297. So to get the other one, we subtracted 180. So I'm going to go back to my calculator and take that answer and subtract 180 degrees, which is the same thing as pi radians. And my other radian measure is 2.034. So there are our answers, 2 from the unit circle and 2 from the quadratic, or from the calculator, because negative 2 was not on the unit circle. I was thinking ahead here. I saw the next problem, so I was thinking about the quadratic formula here. It says to solve the equation by using the quadratic equation. I'm assuming we all remember the quadratic formula being negative b plus or minus the square root of b squared minus 4ac all over 2a. So here, I'm going to go ahead and distribute to remove the parentheses. Cotangent times cotangent is cotangent squared. 3 times cotangent is cotangent. And I'm going to move the 1 over, so we're set equal to 0. So first of all, this is not factorable because there's nothing I can multiply together to get 3 that will get me, or multiply together to get 1 that will get me 3. So that means I'll just identify a to be 1, b to be 3, and c to be negative 1. Right here, a, b, and c. So I'm going to plug that in to our quadratic formula over here, negative 3 plus or minus 3 squared minus 4 times a times c all over 2 times a. Doing some simplifying here, negative 3 plus or minus the square root of 13 all over 2. So that's what our x equals, negative 3 plus the square root of 13 over 2, and negative 3 minus the square root of 13 over 2. Well, this is complicated by the fact that we're working with cotangent. Cotangent's not on our calculator, so we use our inverse tangent functions. I'm going to go ahead and write this out. It'll be 1 over negative 3 plus the square root of 13 over 2, and the inverse tangent of 1 over negative 3 minus the square root of 13 over 2. Now when I pull up my calculator here, I'm going to shortcut that just a little bit because 1 divided by this fraction just means the fraction is flipped over as reciprocal. So I have second tangent of 2 divided by, and I have negative 3 plus the square root of 13. Now let's go ahead and do this. I'm going to make life simple here. So I'm going to do it from 0 to 360 rather than for all solutions, and definitely not in radians. So I'm going to go down here, back and change my calculator over to degrees. Before I hit enter, I've typed in the first part here, and I get, I'm going to make life simple and say 73 degrees. So I get an answer of 73 degrees. I'm going to put my answers up over here. So 73 degrees is one answer. Okay, 73 degrees is in quadrant number 1. So this function is also positive in quadrant number 4. So I would add 180 and get 253 degrees. So those are the answers from the first half. We have 2. Then I'll just repeat the process here. The inverse tangent of 2 divided by negative 3 minus the square root of 13. And that gets me negative 16 degrees. So as we talked about in the previous problem, negative 16 doesn't fall between 0 and 360. So I'll add 360 to make it a coterminal angle, and that will get me 344 degrees. So 344 degrees will be our angle in the fourth quadrant, which means I want to move 180 degrees away to the second quadrant and get 164 degrees. So there's our 4 answers by using the quadratic formula to solve rather than factoring. And it looks like we have one more here. We have tangent plus the square root of 3 equals a secant. It says to solve by squaring. So we're going to square both sides. That would give me tangent x plus the square root of 3 times itself. Tangent x plus square root of 3 equals secant squared. Or tangent squared x plus 2 square root of 3 times the tangent of x and plus 3 back equal to secant squared. Okay, so now notice we have 2 separate functions here. So I'm going to leave the tangent squared, the 2 square root of 3 times tangent and the plus 3. And I'm going to change secant squared to be 1 plus tangent squared. That way I have the same function all the way through. To solve, or we'll combine like terms, so I'll subtract 1 from both sides. Also subtract tangent squared from both sides. That way I have it set equal to 0 over here. Tangent squared minus tangent squared cancels out to be 0. 3 minus 1 is plus 2 equals 0. So I could go a step further and divide through by 2 here, and I have square root of 3 times a tangent plus 1 equals 0. Square root of 3 times tangent x equals negative 1. Divide by square root of 3. So tangent x equals negative square root of 3 over 3. Again, I'm shortcutting here, a little rationalize the denominator. This answer is on our unit circle, occurs in quadrant number 2. Let's go between 0 and 360 again, just to make our life as simple as possible. So negative square root of 3 over 3 occurs at 150 degrees in quadrant number 2. Tangent is also negative in quadrant number 4, so that's going to occur at 330 degrees. Now this one, notice it says to solve for extraneous solutions, so we have to go back here and make sure that our angles both satisfy our equation here. I'm not big on space here, so I'm going to go with a tangent of 150 plus the square root of 3. Let's try that again. Equals the secant of 150. Okay, so the tangent of negative 150 is negative square root of 3 over 3. The secant of 150 is going to be 2 over the square root of 3, or 2 square root of 3 over 3. Just pulling those values off our unit circle. Again, I'm running out of space here, so I'm actually going to come up here and try and erase some of this so I have some room to work with. Maybe it might take me a minute. So we'll do some math here with this equation. I have negative square root of 3 over 3 plus square root of 3, I'll put that over 1 for just a visual effect, and 2 square root of 3 over 3 negative for our secant of 150. Again, those values are coming straight off the unit circle, so I will rewrite this as 3 over 3, and negative 1 square root of 3 minus or plus 3 square root of 3 is 2 square root of 3 over 3. Does that equal negative 2 square root of 3 over 3? No, it does not, so 150 is not an answer. Now I'll do the same thing with 330, so the tangent of x, tangent of 330 plus the square root of 3 equals the secant of 330. This time, this is negative square root of 3 over 3 plus the square root of 3. For visual effect, I'll put that over 1. The secant of 330 is going to be 2 square root of 3 over 3. It's going to be positive this time. So notice when I put the 3 in here, I'm going to get 2 square root of 3 equals 2 square root of 3. So this one, or 330, does work. There's our only solution. And that is our solving of trig equations.